Let's see the first question. Explain what's wrong with the following improvement of the statement square root 3 equals to negative square root 3. And the proof said, let's start by assuming square root 3 equals to minus square root 3. This is correct because we want to prove this, so we just assume this. And then we square both sides, giving the statement 3 equals to 3. And this is also correct. When we square root both sides, we got this. And this is clearly a true statement, therefore our initial assumption must also be true. Therefore square root 3 equals to minus square root 3. This is wrong, because this proof proved square root 3 to the power of 2 equals to negative square root 3 to the power of 2. They proved this, which is 3 equals to 3. This is correct, which means square root 3 equals to negative square root 3 implies their square are equal. This is correct. Then it gives the conclusion their squares are equal implies square root 3 equals to negative square root 3. This is wrong, because if we give two real numbers a and b, if a equals to b, which implies a squared equals to b squared, this is true. But a squared equals to b squared implies a equals to b. This is false. Just same as here. Because these two statements, they are not equal. When a equals to minus b, a squared also equals to b squared. Therefore, a squared equals to b squared does not imply a equals to b, because when a squared equals to b squared, we have two situations, not only a equals b, also a equals to minus b. So a equals to b implies this, but this does not imply a equals to b. Therefore, we can't get the conclusion that square root 3 equals to negative square root 3 by proof their squares are equal. This is wrong. So that's why the first question is incorrect. Let's see the second question. Consider the following incorrect proof that if x squared is even, then x is even, which means we need to prove that x squared is even implies x is even. But in the proof, we can see it started by assume x is even. I think here is already wrong, because they want us to prove if x squared is even. So we need to start by assume x squared is even, but not x is even. And we can see the whole proof is using x is even to finally to get the answer x squared is even, which means this whole proof is use x is even to get x squared is even, which means it proved x is even implies x squared is even. But actually, these two statements, they are not equal, because we can just get a simple example, like we have two statements a and b. We can see a as x is even and b is x squared is even. And the truth table of a implies b and b implies a. Actually, they are not the same, because we can see the truth table here. When a is true, b is false. A implies b is false, but b implies a is true. When a is false, b is true. A implies b is true, but b implies a is false, which means these two statements, they are not equal. When these are not equal, that means we can't get the conclusion that x squared is even implies x is even by just prove that x is even implies x squared is even, because they're not the equal relationship. That's all. Thank you.